Hi guys, here's the video over Unit 8 Part 1, Day 4, Angles and Radians. So what we're doing today with these notes is just converting back and forth between radians and degrees. So a radian is another way to measure an angle, just like we can measure length in feet and inches or yards or centimeters. We have all of those different ways to measure length. We have two different ways to measure angles. We have radians and degrees. We have these conversions over here, pi over 180 and 180 over pi. That comes from the fact that 180 degrees is equivalent to pi radians. So if I'm trying to convert back and forth, I'm looking at what I'm starting with. So in this case, I'm starting with 30 degrees. And I'm going to multiply it by either pi over 180 or 180 over pi. The way that I know which one I'm going to multiply by depends on your original units. So in this case, our original units are degrees, which means I want to cancel out the degrees. So the degrees need to be on the bottom. That way, I can cancel out those units. And since 180 degrees is on the bottom, that means pi is on the top. So I can go ahead and multiply straight across. So that's 30 pi over 180, which reduces to 1 pi over 6. So that means the angle measurement for 30 degrees in radians is pi over 6 radians. For letter B, I'm starting with radians, which means I want to change it to degrees. So since I'm starting with radians, I want to be able to cancel out the radians, so my pi has to be on the bottom, which means 180 degrees is on the top. So your pi's are going to cancel. I can go ahead and multiply straight across. So negative 5 times 180 is negative 90, or negative 900 degrees over 3. And then I can divide negative 900 by 3, so that gives me negative 300 degrees. For letter C, I'm starting with degrees, so 135 degrees, which means my degrees has to be on the bottom. So 180 degrees on the bottom, which leaves pi at the top. My degrees are going to cancel. So that gives me 135 pi over 180. 135 divided by 180, reduce it, is going to be 3 pi over 4. And then for letter D, I'm starting with radians. So I need to cancel out the radians. So my pi is on the bottom, 180 degrees is on the top. So pi's cancel. I can multiply straight across. Negative 11 times 180 is negative 1,980 over 6. I can divide that by 6, and that gives me negative 330 degrees. So that's just converting back and forth between radians and degrees. For the second example, we are looking at coterminal angles. So coterminal angles, when two angles in standard position have the same terminal sides, they are called coterminal angles. You can find an angle that is coterminal to a given angle by adding or subtracting a multiple of 360. In radian measure, a coterminal angle is found by adding or subtracting a multiple of 2 pi. So coterminal angles, I'm just going to draw a picture really quick. Let's say I have this angle measurement drawn over here. So here's my initial side, there's my terminal side, there's your angle measurements. Now this angle measurement could be measured by what I have in green, or I could also go around a full rotation and stop right there, and it's going to give me the same physical drawing of that angle. Those are what coterminal angles do. So let's get rid of this and actually calculate it. So for 210 degrees, I want to find one positive coterminal angle and one negative coterminal angle. So I'm going to start with my 210, and I want to add a full rotation, which in degrees is 360 degrees. So 210 plus 360 is 570 degrees. So that means if I were to actually sketch the angle for 210 and sketch the angle for 570 degrees, it would give me the same picture because they're coterminal. For the negative, I have 210 degrees minus 360 degrees. So 210 minus 360 is negative 150 degrees. So all three of these angles, the 210, 570, and negative 150, are all coterminal. So if I were to sketch any three of them, it would give me the same image. In terms of radians, for a positive coterminal angle, I'm going to add a full rotation, which is 2 pi. So I have 7 pi over 3, or 7/3, plus 2 is going to give me 13/3, so that's 13 pi over 3. For my negative coterminal angle, 7 pi over 3 minus a full rotation, so 7/3 minus 2 is 1 pi over 3. Now this is not negative, it's still positive, which means we need to subtract another rotation. So I'm taking 1/3 minus 2, which gives me negative 5 pi over 3. And again, if I were to actually sketch 7 pi over 3, 13 pi over 3, and negative 5 pi over 3, it would give me the same graph. Um, 9 pi over 4, again, positive coterminal angle, I'm going to add a full rotation, so I am adding 2 pi, so I have 9/4 plus 2 is going to give me 17 pi over 4. So that's my positive coterminal angle. For my negative coterminal angle, I'm taking 9 pi over 4 and subtracting a full rotation. So 9/4 minus 2 is 1 pi over 4. It's still positive, which means 1 pi over 4 counts as a positive coterminal angle, but we wanted a negative one, so I'm going to subtract 2 pi again, and that gives me negative 7 pi over 4. And finally, 150 degrees. Positive coterminal angle, I'm going to add 360 degrees. That gives me 510 degrees. And then for the negative coterminal angle, I have 150 degrees minus 360 degrees is negative 210 degrees. Alright, so that covers everything for day 4, angles and radians.